Okay, we completed our bidirectional motor sonic sensor. What is next? Let's look at our program. Yes, this is our program. This is just how we make our program. The program is actually here. You have to clearly define what you want. Anyway, we have these pieces of hardware coded. We have a sonic sensor that's coded now. Next thing to code is an angular stepper motor, and it only requires one pin. And keeping in tradition with our hardware coding and our standardized methods, we are going to do it exactly the same way we did the first two objects. A little bit of differences because it's a different object, but same mantra. And we're going to make a new class, and this time we are going to set our nice alcoholic beverage down and get to it. Alright, angular stepper motor, and we've got to capitalize it. There we go. And of course, to build one from the idea, we need, I don't know, we need bigger, a blueprint. We need a blueprint. And of course we need to name the file something we can remember. There we go. Angular stepper motor. And finish. As before. And you have to Rawze. Go here, get rid of this stuff I don't like, I'm not going to use. Has the template made, or the Eclipse plop down for me. And we have a class, it is a blueprint, and we have a private area, a public area, and okay. Now that we have that, we need a single pin on the Arduino. It's going to be a PWM, pulse width modulation output pin. And it's actually a stepper motor, and I want to use, we can include the Arduino library, so we can mess with the pins on the Arduino board chip. But I also want to use the stepper library that comes with the Arduino software, in this case, like they did in the original program, just for reference sake. The original program for this thing, they use the Servo.h library, and down here somewhere they define what pin it is. There it is. So instead of like pin mode with the pin and all this, when you use the servo library in Arduino, you have to say, the servo, whatever you call that servo, which in case they called it my servo, which, it's okay, I guess. You have to say attach, and then what pin on the Arduino chip, which is actually PWM. So we'll stick with that, just so that we have consistency with how it was originally done. So we'll include the actual Servo.h library, and you'll notice that I think I want to show this because I haven't covered it. See how that has brackets greater than less sign brackets on either side, little bracket. It's my understanding if you have the quotation marks around it, it goes and looks for it in the library folder as such. But if you have these on either side of it, what it'll do, I think the compiler, or the pre-compiler, the secretary, I think it'll actually do a search for the file and go look for it. Not guarantee it's going to find it, but I don't. I think that's the difference. I always just use the quotations. So we're going to include the servo library, we need the actual an actual object. It's obviously going to have a private member. Only whatever pin is required for that servo, which we know is pin 9, looking at the other program. What do we want to call it? We can call it PWM pin. It kind of looks kind of that kind of looks cryptic to me, calling it PWM pin. Why don't we call it control pin? That, I think, looks pretty good. And of course, it's going to be 8-bit, just like all the other pins on the Arduino board. And then, of course, it's not going to change when we create the blueprint, so we're going to make it a constant. And we'll start there. Now, that looks pretty good. We also need this actual object, or to make an actual servo motor from the Arduino library. So we're going to say they don't use the word blueprint. Most of the world don't. They use the actual object name, which it's okay too. But I think it's a little cryptic when you do that. We're going to say servo, which is the class or object name for what the Arduino library calls a servo. And we're going to say servo motor. There we go. And now we've created an actual unit from the idea of a servo in the Arduino Servo library. And then, of course, it's going to be private as well. So we'll say, hey, this is a member only. We're just going to put that in there so that we remind ourselves every time we use it. It only belongs to this blueprint. It's not public. And then we have some timing issues with servo motors. Anytime you have, let me grab this robot. Anytime you have something that moves, like this little set of eyes, it moves. Okay, it moves this way, it moves that way, and that's the servo motor we're programming. And it's an angular stepper motor. Actually, this is what this thing is. It's angular. In other words, if we send to this Arduino library, if we send a command to this Arduino library's definition of this servo motor, it's going to be the angle. And angle, and I think when I looked in the other program I played with before, angle 0 is actually over here, 90 is in front, and 180 is over here. So we'll deal with that. But anytime you work with, a microprocessor, a controller, a board, or whatever, and it has to manipulate something in a real device. That device, it takes time to go from, let's say we say move it from here to the far right. It takes time for it to actually go from here over to here. Looking at it kind of in slow motion. Let's say we say 0 and then we say 180. Well, that takes amount of time, amount of number of milliseconds, microseconds, seconds, minutes, hours. It takes time. And of course, the microprocessor, in relevance of time, even this little tiny Arduino board here, even this little Arduino Uno, I think it is, it'll process about 1.5 million lines of code per second when it's running and there's nothing stopping it or slowing it down. So what's to say I don't say, hey, this thing here, go to the far right, go to 180 degrees. And of course, if I don't wait for that to happen, the next line of code might be, check where you're at. Check to see what's in front of you. Well, if I say, go to the far right, check what's in front of you, if I wait for it to get to the far right, that's great. But if I don't somehow figure out how much time it's going to take to go and get there, I might be reading it straightforward because I didn't wait. And then it's going to turn afterwards. And a million, several millions of lines of code later, it might be over here. And I've already done that function. I've already done that task, and I get a bad reading. So we have to synchronize time with this guy here that wants to run 1 million lines of code a second. So how we do that is we figure out how much time it takes to go from its one extreme to the other. Okay, so how long does it take to go from here all the way to here? And if we know that, how much time it takes to go all the way, and then we add a tiny bit to it so that we ensure it always gets there, Then if we say, if we want to go from here to here, maybe half that distance, we can divide that amount of time it takes to go the full distance in half and say, okay, it's going to take this amount of time to get there. If we want to go a third of the way this way, or a third of the way from where it was at to where we got to go, or a quarter, or a tenth, or 1/5, we can divide that time it takes to go from one by a fifth or a third, or whatever the difference is. So it's appropriate to do a little bit of math to find out how long it's going to take, because we don't have a feedback. There's no pin that says, hey, I'm in position, or there's no pin that says, hey, I'm not quite there yet, or some kind of feedback. So we can estimate it, and that estimation can get us close enough that we don't really have to worry about it, for all intensive purposes. And if you're not sure if the estimate's accurate or not, well, just add a little bit of time past the estimate to ensure that, hey, it has gone there and stopped and settled, and then move on. So that's what we also need to do. So in that process, though, we need to know something about time itself. We need to know, let's say I commanded to go to the far right. I need to know when I did that, when I set that command. Of course, let's say it's going to be here, and I say, go to the far right. Well, I need to know exactly when I sent that command to this to say, go to the far right, so that I can then later say, hey, when did I say that? 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 And minus how long it takes, when did I say that? Oh, that amount of time has passed. So I need a way to store when I gave it its last command to go somewhere, and then measure the amount of time it's taking, or they measure the amount of time. And of course, I also need in this motor, I need a way to know if it has reached that point or not. So we're going to add some functionality. The bidirectional motor was dumb as a brick, basically. The sonic sensor had a little bit of sensor feedback and did some math to give us a more accurate, measurement of centimeters. This thing here, we're going to do some estimation. And we're going to give it a couple of abilities. One, we're going to tell it where to go. Okay? Because it's an angular stepper motor, 0 will be here, 180 will be here, or 0 will be here, and 180 will be here, whichever way it's wired, I guess, or whichever way it's programmed. And then, of course, we need a command to tell it where we want it to go, and we also need a way to check to see if it has reached that point. And that's important, because maybe our program doesn't care how long it takes. Maybe we write one kind of robot that's got a stepper motor that don't have a sensor. Maybe it's just got a stepper motor that performs a task and we don't care. So remember, we're just programming an angular stepper motor at this point. We're not programming the eyes yet. So maybe we have a kind of program where an angular stepper motor, we say, hey, go up and go this direction, and we continue on with our program, and we don't care how long it took. That's one scenario. Another one would be, go over here and wait until you've reached that point. So we need that option. We need to be able to optionally say, go and wait until you get there, or go and then give me the information. Only tell me when you're there or not. Let's do something after you reach that position, or go and I don't care. So we'll have two functions. We'll have one, and we'll make them public so that we can access, or anything can access them. So we'll have one public function that will say set, because it's an angular stepper motor, angle, right? And of course we can tell it what angle we want. Let me set this robot down. We can tell it what angle we want. Here we go. And of course we can have one that say, are you there yet? How about we call it has motor arrived? How about that? Has motor arrived? Or has... it looks pretty good. Has motor arrived? That sounds good. Of course, set angle, we don't need to give us any poop. We just say, go do it. Go set the angle. So we're going to say void. We don't need any information back. Now, has motor arrived? True or false? That's a true or false. Has it arrived yet? Yes or no? So we're going to make that a Boolean. BOL is true or false. Boolean logic. So that's what that is. So those are two things, and of course we need to initialize the servo motor, just like we initialize, pin mode and all this stuff when we boot the processor up and we, turn the key to the start and crank the engine, kind of thing. So we need a begin routine, just like all of our other objects. And this is starting to look really, really kind of familiar. Our objects all have private things, private, pins and settings. They all have begin routines. They all have tasks that you can do. They all have, this one actually has a task you can do and have you finished that task, which is kind of something new. And begin routine doesn't need we don't need anything back from that. We just say, hey, go do it. So that looks good. But now we need to keep track of time, because if we set the angle, we need to know, for us to be able to answer this, has it arrived yet or not, we need to be able to know when we set it versus right now, and has that time passed. So privately, the amount of time is tracked in the Arduino most commonly in milliseconds, and that's a 32-bit value. That's a UINT32 T data type, and when was last set. How about that? We'll call it when was last set, and we'll give it M underscore. Make it member only, or just so we can reference it and know that it's a member only thing. When the angle was last set. When was last set? That looks pretty good. That looks pretty solid. We also need we need a way to set this pin number, the control pin number here, this constant. So to do that, we can do that during this construction, and it's required to do during the construction because it's a constant. It's the only place we can set it, because once the code gets up and running, it's constant. It's a static value. So we say blueprint, the name of our class, and hey, what do we want to do during the building of this blueprint? We want to feed it some information, and then what pin number. So control pin number. Here we go. That looks pretty good. That looks pretty good. That's what we want. That's our idea. We have a blueprint. We have a control pin. We're going to use the Arduino library to make a servo motor, a actual unit called M underscore servo motor. When did we last set the angle? So we can keep track of time, so that we can determine how much time has passed since it was between it being set and when it might have arrived. And we have a way to ask, hey, has it arrived yet? And then we have a begin routine to initialize our servo motor and set the pin as output, blah 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 blah. That looks good. Now we can right click and we can hit source implement method in our Eclipse software, because I just love that feature, man. It's just like the best feature that they put in here in this software. And then of course it creates all these templates, hey, in the Angular stepper motor blueprint, the blueprint constructor, make a context to show you how to do that task. And of course, same thing here. In the idea of a stepper motor, Angular stepper motor blueprint, the begin routine, the definition of how to do a begin routine is in this context. Of course, that's what this all means. So, when we create our blueprint, it's going to be just like our other ones. Here's what it's asking for. Here is what we want it to perform during the construction of the blueprint. As it's being constructed, what code we want to run. We don't run any code, but we want to do a by the way, because I'm asking for data and I have a private member to store that data, or place to store that data. By the way, M underscore control pin, I want you to eat, or to be set to, or to ingest the value of whatever created this thing into our private area. There we go. And of course, it's still giving us, hey, when was last set? Is not set. You see that? We have another variable. It's giving us a warning saying, okay, so you defined this, and you didn't define this. And this is not going to be a constant, because we're going to set this. We're going to set this value every time we set angle. We're going to reset this value. It was just last set, so we don't need it a constant. But we do need to set it initially, just something. When was it last set? Never. So I'm going to go M underscore when was last set. What do we call that thing? Maybe I misspelled it. Copy. when was last set, I want you to ingest or be preset to nothing. There we go. Now what's wrong? Because I keep putting that semicolon. There we go. Comma. Because I'm doing multiple things. So I'm saying, by the way, do this and do this. There we go. So when the loop is created, ask for a control pin. Set that control pin as our, whatever value was supplied, store that as our private control pin number, as our control pin, and then set the time of when it was last set to 0 because we are just starting up the routine. Looks good. Angular stepper motor begin. Of course, we're using the Arduino Servo library in this case, which I'm not sure if it's being included. So let's go here, add a library, and yeah, there's 2 libraries. I have 2 of them in my collection here. I have Servo, and that's actually for SP2 or that IoT ESP8266, whatever that thing is. I don't want that one. I want the Servo Arduino library. So that's correct. Sometimes you have to actually tell the software, the editing software, what libraries you want to include, so that they'll show up down here on this far left. You can see Servo Arduino's in there. So we did that to make sure. And then of course we're using, this is the name of our device. We don't refer to the blueprint once we create the device. The name of our device, that's what we want to manipulate. And we want to say the servo motor dot attach, and then of course a pin number, and a pin number is going to be our control pin, our private value for control pin. So that will be the same as saying pin mode this and this and that and blah blah blah. You can probably go in here and follow that library and find out all the garbage it's doing. That's programmerese to me. So, ugh. But I'm not a guy who wrote Arduino software. If I was, it would look very, very different. Anyways, that gets us on the servo motor. Now, has motor arrived? This is a little tricky one. Well, we haven't even determined this yet, so let's skip that for now. Let's just set the angle. What we can do next is we can set the angle, and how we can set the angle. Let me get a drink of water here. Get something to drink. My beer hole runneth dry. Okay. Now, to set the angle, all we have to do is say our servo motor dot right, because we're using the Arduino library for the servo motor, and of course our angle. Okay. But there's some issues with that, and the issues are that it takes time for it to arrive. Okay, and so what we can do is we can say, after we set our angle, we can say m underscore when was last set is equal to the number of milliseconds since this Arduino board has been booted up. And that's one way of tracking time. It's one of the most common ways of tracking time. That's an Arduino function. It gives you back the number of milliseconds since the thing has been booted up and turned on. So that'll give us a timestamp. When was last set? Well, right now, the number of milliseconds that has passed right now since it's been turned on. And that'll give us when it was set. Now, here's the trouble. Let's say I'm working with this thing, and I'm saying set the angle to, let's say, 90. 90 is straightforward on this thing, by the way. 0 is over here, 180 is over here. 90. Let's say I set it to 90. Okay, and it's at 90. Let's say I keep setting it to 90 over and over and over and over. Let's say I want to say set it to 90, check to see what's in front of you. Set it to 90, check to see what's in front of you. Set it to 90, check to see what's in front of you. And if it's already there, I don't need to keep updating this timestamp. And I also don't need to write that position to my servo motor, because it's already arrived. There's no reason to update that information or to perform this task if it's already sitting where I've asked it to go. So I need a way to track that. Now, there's a couple of ways to do that. I can make a static variable. I don't think I've covered static variables yet. So I think I'll actually do a static variable, but I don't really like to do it that much. It's kind of poor practice to do it inside the function because it's buried in the function. Most people don't know it exists, and it's like, oh, wow, it's like it's kind of crazy to do a static variable sometimes, unless you just absolutely have to inside the function. But you could make a static. What I'm saying is you can do static, and then you could call something last angle setting, right? That's the last time it was set, and equal to, of course you do it that way, and of course you tell it what kind of data types, 8-bit, because that's what we're working with. UINT8. Of course, on a separate line, you have to leave it on a line by itself. Don't preset it to anything. That way it's not set to 0 every time this routine runs. If you say, hey, I have a static variable, I want you to remember, between calls, I want you to remember what this last setting was. I can then say last angle setting equals to angle. Right? Now, in between calls of this, it will remember this value, like the last time it was set. Of course, we can do this. We need to do this after we perform our task because it doesn't actually. Yeah, I just like to keep things in the correct sequence. Perform your task and then save what you did and when you did it, not beforehand. That's more correct, more politically correct. We can do that, and it'll work, okay? But it's kind of obscure. It's kind of hidden down in here. Yeah, it's a 50-50 call. I like to do it privately in the blueprint. I like to just keep track of stuff in the blueprint. So I'll make another private variable. And it doesn't need to be static, of course. It just needs to be 8-bit integer, the last angle setting. And of course, when we do it that way, we need to initialize it with our blueprint initialization, just like we did the other variable. Now suddenly we need, of course, we'll make it a member only. We'll refer to it as m underscore. So we know that, keeping with our standardization. The last angle setting was 0, or not set actually. I did that almighty. There we go. I think that's a little more appropriate. That way it can be easily seen, and it's yeah. And also, it's not just particular to this exact function. In case I need it over here, or somewhere else, I can get to that. And of course, this is m underscore. There we go. So we're performing the same task here. Write the angle, save what we set it to just now as last angle, and also, when did we set it? Well, we just set it now. With this last angle setting equals angle. Okay, with this, once we say, hey, we set it to this, now we know what it has been set to last. So if we go to the almighty if statement, if, and we go angle, and let's make this a little more politically correct, even though we could type it that way. If angle is equal to the last time we set it, then I don't want you to do anything. I just want you to return. I want you to just skedaddle. Don't bother to process this function if it's already been set. That if I've set the angle, then and it's equal to what I set it to last, and I call it again, I don't want it to do this stuff. It's already there. It's already got a timestamp. So if I call it 1,000,000 times a second, it's gonna set it the first time. It's gonna timestamp it, and it's just gonna say, okay, it's been timestamped. I don't need to do it again. That's pretty good. I think that's what we need right there. Now, we know for a fact, though. We're not setting it. We're doing equals. We're comparing it. You see how that got me? It's gotten me twice since the beginning of this tutorial. And maybe I should take a second to just talk about that. That's one of the gotchas in C++. You say if angle equals this, and I can't tell you, when I first started coding in C++, how many times I would do that mistake, this mistake right here. You know, I'm not saying, hey, is it equal? I'm saying what this actually does is it says, is this equal to this? Yes or no? But by the way, before you exit this logic, set this to this after you've done the compare and move on. That's very cryptic, and it doesn't show clearly that that's what it's doing. I don't know why they allow this in C++. I think there's reason to, but it's one of those gotchas. I can't tell you how many times over the past years I've written programs and I've actually done this mistake right here where I want to compare something, but I accidentally only use one equal sign, and I'll spend hours and hours scratching and pulling my hair out and cursing. There's nothing wrong. Why doesn't this work? And then eventually having to step through the code line by line to figure out, oh crap. Yeah. So, just thought I'd note that. It's a very common mistake that gets a lot of people. And I think that whoever wrote this programming language should have made this, this warning. The Clip software gives you this warning, but it's obscure, possible assignment. So, that's how I catch it usually, is I looked at that yellow. But the Arduino software, it doesn't have those warnings live like that as you're typing. So it's easy to make that mistake with certain programming editors, certain development environments. And like right here, we got this little tag here. It says, hey, you didn't return anything yet. That's because we haven't written that routine yet, so we know that. But I think that's going to get us. And of course, if we know when it was last set, okay, we can come up here and we can say, if millis, which is now, minus when it was last set, is greater than, of course, time it takes to get there, then we can return true. And then, of course, else, we're not there yet. Return false. That would be one way to do it. But the time it takes to get there, obviously, this time it takes to get there, we would have to make a variable to say, we can make that a constant value. We can say, okay, time it takes to get there is always going to be the amount of time it takes to go from here all the way to here. So we can just say, hey, just always wait that amount of time. And of course, it kind of sucks because you only have to go from here to here, or here to here, or here to here. You're going to wait the time it takes to go from here to here every time. It kind of slows us down unnecessarily. So I think what I want to do is I want to do some math. I want to figure out how long it takes to go from here all the way to here, and then in this routine here, okay, going back to this, we know what the difference between these two are, right? This is from here to here is going to be a certain amount of difference, and that difference, from that difference, we could divide the amount it takes to go from one extreme all the way to the other, and divide that by our difference, and then only have to wait that amount of time. That'd be kind of cool. So let me go. I've got it. I think I dug somewhere else, and I figured out how long this was exactly. So let me go find that and come back. All right. I wrote a temporary little file here, or program here. Angular stepper motor, pin 9 on the robot, and then I put set angle to 0, set angle to 180, which is minimum maximum, of course, and I put a delay time of 650 milliseconds, And you can see that it's moving back and forth and waiting just a moment. So it's about 650 milliseconds to go from one end to the other. Let's say if I put it at 550. Let's see what happens when I put it at 550. Flash that in. Still comes to a complete stop. What about 450? I figured I'd show this because that's how I figured it out last time. There I have 450. And it's still stopping all the way, but just barely. Let's set it at 350. Now it's not stopping at all, it's just continuous motion. So that means there's no time for the motor to settle in between motions. So it's going to be 450, it's going to be a minimum. It clearly stops at 450, but just barely. So how about we just set it to 550, just to be safe. That gives us a little cushion. A little much of a cushion. 500. 500 it is. That sounds good to me. So it goes from 0 to 180, 0, 180, 0, 180, and it completely stops. I can hear it completely coming to a stop before it goes the other direction. So it takes about 500 milliseconds for this thing to go full angle from 0 to 180. So if we take our little calculator, I'm going to set this down. I take our little calculator and we say 180 divided by 500 milliseconds is equal to actually it's the other way around. Yeah, 500 divided by 180, 180 degrees is, you see that, 2.77 or 2.75, 2.77, 2.78. Let's just call it 2.78. So if I take whatever the two angles are, let's say I go 2 degrees, and I multiply that times 2.8 or 2.78, that'll give me roughly, with a cushion, the amount of time it's going to take to get there. If I go 45 degrees from one angle to another, say I was at 45, I go plus 45, that's 90. If I go 90 degrees and I multiply that times 2.78, that's going to get me the amount of time it's going to actually probably arrive. So let's do it that way. That'd be cool. That way we don't have to delay as little as possible. And hey, don't run off. There you go. Yeah.